All right, let's move on to the next one. So we want to have everything factored first so that we can find the LCD. LCD. But in this case, everything's already factored, so the LCD is going to include an x plus 5, and it's going to include an x minus 2. And since it appears once here at the beginning, right? So you have this one, x plus 5, and this right here, x minus 2. You don't need to repeat it because it appears again, right? Each one of these parentheses only appears once, right? That's the 1 power, 1 power, 1 power, 1 power. So you only include them once in the LCD. If you had one of them appear more than once, you'd have to include it to that higher power. But since each one of these parentheses only appears once in the denominator, in the LCD you only include it once. I know my handwriting's a little bad, but hopefully that makes sense. Okay, so now we're going to multiply this entire thing by x plus 5 and x minus 2. Okay, so we're going to distribute it. Now in the first one, we keep the 3, but the x plus 5 in the bottom is going to cancel out with the x plus 5, leaving me the x minus 2, plus we keep the 5. Now the x minus 2 on the bottom will cancel out with the x minus 2 that I'm distributing, right? And that leaves me the x plus 5 equals, and then I distribute to the other side of the equation. Make sure you hit every term on both sides of the equation. If you miss one, you're going to get the wrong answer. And in this case, both of the denominators cancel out, right? The entire denominator of x plus 5 and x minus 2 cancels out, just leaving you the 35. Okay, now this is a nice little linear equation to solve, not too bad. So we got rid of the fractions. The next step is going to be to distribute. 3 times x is 3x, and 3 times negative 2 is negative 6. All right, so then we distribute the 5. All right, so 5 times x is 5x. 5 times 5 is 25, and we keep the 35. All right, next I want to combine like terms. After distribution, you combine like terms. We have a 3x and we have a 5x. 3 plus 5 is 8. So we end up with 8x. And then next we combine negative 6 and plus 25. So 25 minus 6 is going to be positive 19. And we have that equal to 35. Next, we want to get all the variables on one side. Check, already done. We will get all the constants on the other side. So minus 19, cancel, cancel, ends up with 8x is equal to, and this is going to be a 16, right? 35 minus 19 is 16. Let me finish it over here. So we end up with 8x is equal to 16. Next, we undo the multiplication of x by 8 by dividing by 8. Whatever we do to one side, we do to the other, gives me x equal to 2. Now, I need to go back and double check, okay, because this LCD, right? So either x plus 5 equal to 0, right? Minus 5, cancel, cancel. X is equal to negative 5, so that would make that 0. Or x minus 2 is equal to 0, in which case plus 2, cancel, cancel. X is equal to 2. And this is where the problem happens. Because even though all the algebra is fine at this point, if I would plug that back into the original equation, it wouldn't make it true. It would make it undefined, right? So we're not able to have this as the answer. So that actually is not going to be the answer. Now, technically, whenever you get the answer, you don't want to leave it as x is equal to. You're going to put it in these, the set notation. So in this case, well, you wouldn't use set notation on this, but in this case, you could do this. You can put empty set, null set. Different ways of getting the same idea: empty or null set, null, not null set, null set. These are enter and null set, or you have this symbol, right? They all kind of mean the same thing. Okay, and that's it. Okay, let's try a couple more of these. So we have an x plus 2, and an x minus 2, and we have an x squared minus 4. Now, we have to factor everything first because it's not factored this time. So if I factored that out, I would end up with an x plus 2, x minus 2. So we know the LCD would include each of these to the highest power. They only each occur once, so we just include each once. So you have to include the x plus 2 and the x minus 2. Okay. So what I'm going to do is I'm going to multiply this entire equation by this LCD. Okay, so I'm just going to, I know this is really messy. Okay, so we keep the 4. Boop, but the x plus 2 cancels out because I'm multiplying by the LCD, leaving me the x minus 2. Then minus 1. but the x minus 2 is going to cancel out on this one because that's in the denominator, leaving me the x plus 2. Okay, then I have the 5x on top, but because the denominator x plus 2 and x minus 2 is on the bottom, they cancel out, and you're only left with a numerator of 5x. Okay, so now after getting rid of the denominator, we distribute. So we say 4x minus 4 times negative 2 is negative 8. Then we distribute the negative 1. So negative 1 times positive x is negative x. Negative 1 times positive 2 is negative 2. And then we keep the 5x. Next, after distribution, we combine like terms. We have 4x minus x, and that's an understood or implied 1 there, so that's minus 1. So it's 4 minus 1, or 3x. And then we want to combine the constants, negative 8 minus 2, which will give you a negative 10. And we want to keep the 5x. Next, we want to get all the variables on one side. It doesn't matter whether you get them on the right or the left. If I get them all on the right, I'm going to avoid a negative, so that's what I'm going to do, but you don't have to. It's fine. So I'm going to get rid of this positive 3x on the left by subtracting 3x, and whatever I do to one side, I do to the other. So the left cancels out, leaving me negative 10 there. 5x minus 3x is 2x. Next, I want to undo the multiplication of x by 2 by dividing by 2. Whatever I do to one side, I do to the other. Those two cancel out. And that negative 10 divided by 2 is negative 5. And because the 2's cancel out, it leaves me the x, and that's my answer. Now, I need to double check. If I plug that negative 5 into either of those denominators, will it make it undefined? Will it make it a 0 in the denominator, therefore undefined? And the answer is no. So my answer could not have been a negative 2, and my answer could not have been a positive 2, right? Because that would make it undefined. And I'll just verify that over here. You could just flip the sign mentally and kind of come to the same conclusion. That's fine, but you see, so that would make it equal to 0, right? So to find out what makes something undefined, set the denominator equal to 0, because undefined means you're dividing by 0, or you have a denominator of 0. So how do you find that? Set the denominator equal to 0. It's pretty much in the definition of undefined. So if you ever forget how to find what's undefined, remember what undefined means. It means the denominator is equal to 0. Well, how do I find out what will make it undefined? Well, just substitute it in the definition of undefined, basically. And how do I find out what makes the denominator equal to 0? Well, set the denominator equal to 0, right? So as long as you kind of remember that undefined means the denominator is equal to 0, it pretty much tells you what to do. Set the denominator equal to 0. Okay, and like I said, it looks like negative 2 and 2 will make the denominator equal to 0. But negative 5 looks like it's fine. And when in doubt, you can always just go back and check your work. So if you're under any doubt whether or not your answer will make it undefined or not, plug it in. I mean, if it makes it undefined, it will literally make it undefined. So you don't really have to guess. You can always just check your answer at the end, and it will tell you whether or not your answer is valid, whether or not it made it undefined or not. Okay, so let's try the next one. Next one again, we need to find the LCD, but the second denominator, the one on the other side of the equation on the right side, it is not factored. So we need to factor that. Okay, it's a simple trinomial, meaning it has a one leading coefficient. So I'm going to do the square root of x squared is x. It ends in a negative, which means they have opposite signs. It ends in a negative 12, so I know the multiplication is going to result in a 12. And the middle results in a positive 4. So I'm looking for two numbers that I can multiply together to give you a negative 12, that if I add together would give you a positive 4. Now, because the middle term is positive, I know that the stronger term has to be positive. Okay, so again, we're looking for two things that we can multiply together to get a negative 12. We can look at negative 1 and 12, 2 and 6, 3 and 4. We know the positives are stronger, so those are positive. And we know that the smaller or the less powerful number is going to be negative, the weaker number, the one with the smaller, the lower absolute value, right? So when we multiply it together, we want to get the negative 12, but when we add together, we want to get a positive 4. So we're looking for two numbers that you can add together to give you a positive 4. So it looks like we have a negative 1 plus positive 12, which gives me a positive 11. Nope. We have a negative 2 plus 6, which gives me a positive 4. Check. So we know the combination is going to be the negative 2 and the positive 6. Like that, right? Okay. So here we go. We plug those in. So we have a negative 2 over here, and we have the positive 6 over here. Now you can put x minus 2 first. Or x minus 2 first, and x plus 6 second, because of commutative property of multiplication. You don't really care about the order of that, but you do have to have a negative next to the 2 and a positive next to the 6, otherwise you break it. Okay, now at this point we are going to multiply the entire thing by the LCD, and the LCD is simply going to be each one of these factors, which in this case are these little parenthesis things, right, to the highest power. Now, they never appear more than once at a time, right? So we're going to include the x minus 2 and the x plus 6. Technically, those should be next to each other, not above each other, but I ran out of space. Okay, now, we multiply this through. Okay, so the x minus 2 cancels out. We keep the 1. The x minus 2 cancels out, leaving me the x plus 6. Okay, minus 5. The x plus 6 will cancel out on the second one, like that, leaving me the x minus 2. Should have written that lower, sorry. Next, I'm going to distribute it to the other side, and everything's going to cancel out, leaving me the 8. Next, we distribute. 1 times x plus 6 is simply going to be x plus 6 minus negative 5 times x is going to be negative 5x. Negative 5 times negative 2 is going to be plus 10. We keep the x. After distribution, we combine like terms. We have an x minus 5x, so that's 1 minus 5, or negative 4x. So we have a 6 plus a 10, which will give me a positive, or plus 16. We keep the 8 on the right. Next, we want to get all the variables on one side. Check, already done. We want to get all the constants on the other. Minus 16, cancel, cancel. Negative 4x is equal to 8 minus 16 is negative 8. Next, we want to get rid of or undo the multiplication of x by negative 4 by dividing by negative 4. Whatever we do to one side, we do to the other. Cancel, cancel. We end up with x is equal to negative 8 divided by negative 4. Negative divided by negative is a positive, and 8 divided by 4 is a 2. Okay, now we still need to go check to make sure this is a valid answer. Well, is 2 a valid answer? Let's try the first denominator. X minus 2 equals 0, plus 2, plus 2. Cancel, cancel. X is equal to 2. Uh-oh. That's the undefined list, right? Undefined. If I plug that in, it's going to make that undefined. Right there, right? So this answer, wah, not an answer. So again, we're back down to that, null, set, empty, set. No answer basically as far as you're concerned, right? And that's it.